I'm here to present Renishaw's journey to develop products for the robotic industry. So I started in Renishaw in 2015 with the mandate, the mission to investigate what Renishaw can do for the robotic industry, what we can bring for the robotics world. And the first thing we understood is that metrology in the robotics is often by many people disregarded. It's considered very expensive, time-consuming, and the value provided by metrology is not often well understood. We also found that there exist some metrology solutions for robots, but they are often very, indeed, sometimes expensive and complex, difficult to use. So we really decided to develop a set of solutions as simple as accessible in terms of cost and complexity to be used by many robotic users. We found also that the very first bit of metrology that we want to do in the robotic cell is not to work directly on the robot, but to work on what every robotic integrator does every time is assemble the whole robotic cell, assemble everything around the robot. The first thing you need to do is to locate everything. So we want to provide the very simple tool to help the robot find everything. We have, depending on the situation, this can be done at different times in the life of the robotic cell, during setup, during production, or during maintenance operations. So we have two basic offerings. One is a manual device. This manual device is really dedicated to robot integrators, to the people who program the robot or maintain the robot. It is to be used off production when the production is stopped as a manual tool. And we try to design a new sensor really specific for robots. A simple test with this is, again, robot setup. We can clearly, simply identify work frame, tool frame, part frame, and also to have a better understanding of the status, the quality of the robot over its life. We have a few verification tests to understand the robot performance. How good does it perform? And we can track these results. We can produce this as PDF reports. So it's really now possible and very easy to understand how your robot is performing. This manual device can be also, we can replicate the same feature during production time, because we know that sometimes parts cannot always come at the same position, or sometimes we know that accident may happen, and we want to be ready to recover in no time without the use of integrator coming, just as a simple start of a recovery cycle. So for this, we decided to reuse Renishaw's core technology, which is a touch probe, which is what created Renishaw, is really the invention of the touch probe. So we decided to develop solutions for robots using touch probes. With the probe, we provide all the probing macros, and we provide some side PC for processing the data. So instead of delivering just a touch signal in the robot controller, we now deliver a useful result, which can be updated in the controller and make production work and maintain it. Now, with these two range of products, the ball bar and the probing, we introduce two approaches in setting up the work frames of the machine and also for robot calibration. The initial approach is what we call absolute calibration, which can be done at the time of setting up the robot cell at the beginning of its life. When you set up the robot for the first time, what you want to achieve is to find the ideal best value for your tool frame, for your part frame, for your robot to do the job correctly. Once the robot cell has been correctly set up and we know the environment of the robot, it's now maybe time to make the robot a little bit better. And that's where we decide to use not only one, but three ball bar devices together. This provides us with more concise, more complete, more qualified data. With that, we can work on the robotic arm itself and work on its calibration.